Now the next theorem we move on to after the Fermat theorem is Chinese remainder theorem. Now let's understand what is this. Say I've been given a numerator as n and I split. In the case of Chinese remainder, I split my denominator into x and y. Then first I get a remainder of when n is divided by x, the remainder is a, n is divided by y, I get the remainder as b. And the final remainder is a smallest number which when divided by x leaves a remainder of a and when divided by y leaves a remainder of b. Looks a lot confusing to start with. Let's put this in number, let's put this in solving to understand what is the working of Chinese remainder theorem. So we start up with a number which is 128 raised to 100 divided by 153. The first step of Chinese remainder is what? As I started, you split the denominator. Okay, so I get the number as 128 raised to 100 divided by 153. So can I split the denominator of 153? I can write this as 17 into 9. Okay, so now just compare this with the problem. N is now 128 raised to 100, x is now 17 and y is now 9. So first of all, I'll solve it for n divided by x, which is 128 raised to 100 divided by 17. I'll get the remainder as a. Okay, and that will serve out to my a. Then I'll solve 128 raised to 100 divided by 9. I'll get the remainder as b. So first let us get a and b before we move on to the next part of Chinese remainder. So first to get a, I'll solve 128 raised to 100 divided by 17 and I'll get the remainder of that to be as a. So how do you solve this now? As I see the denominator to be a prime number, first thing that will come into my mind is Fermat theorem. So I'll need the power of 128 to be 1 less than 17. So I'll write 128 raised to 16. Okay, raised to 6. 16 into 6 is 96. What am I left with? 128 raised to 4. Okay, that is something that is left divided by 17. According to Fermat, the remainder for this part is nothing but 1. So 1 raised to 6 into 128 raised to 4 divided by 17. Now I need to solve for 128 raised to 4 divided by 17. What is the remainder for this? I can solve this now by split up. Normal split of 128 into 128 into 128 into 128. That will be divided by 70. Find the remainder for 128 divided by 17, which is nothing but 9. So I'll get 9 4 times. So the same problem can be written as 9 raised to 4 divided by 17. Now to further simplify this, I'll write this as 9 square into 9 square divided by 17. 9 square is 81 into 81 divided by 17. Now I can get 81 square and solve, but I'll solve this by negative remainder. 17 multiples go beyond 81. Minus 85 minus 85. What is 81 minus 85? Minus 4, which is nothing but 16 divided by 17. So my answer for this is 16. So I get my A. Okay, what is my A right now? My A is nothing but 16. Okay, and my X is 17. My N is 128 raised to 100. Just remember how do you put everything there. So my A is 16, my X is 17, and I know my N is nothing but 128 raised to 100. Okay, this for better understanding of what theorem states. Now I'll go ahead and find B. So for that I'll take N, which is 128 raised to 100 divided by Y, which is nothing but 9. Now I need to solve this. This is, I'll solve by split up. 128 multiplied 100 times divided by what? 9. So first find the remainder for 128 raised to divided by 9, which is nothing but 2. 2 into 200 times 2 raised to 100 divided by 9. Now how can I solve this? I am done with the first step, which is split up. Now the second step is adjusting the power. Remember, cut, adjusting the power and all that. So I'll adjust the power to be 2 raised to 3, which is nothing but 8. 3 into 33 will be what? 99. I will be left with one extra 2 there divided by 9. So this is nothing but 8 raised to 33 into 2 divided by 9. 8 divided by 9, negative remainder of minus 1, and that is why I had adjusted the power. Minus 1 will now be multiplied how many times? 33 times. Okay, into 2. Minus 1 multiplied 33 times, which is odd number of times, is nothing but minus 1. Minus 1 into 2 divided by 9. I'll get the answer as minus 2 by 9, but there's an answer of negative remainder. Positive remainder will be 7. Minus 2 plus 9. So now I get my B to be as 7. So my Y is 9 and my B is nothing but 7. Now here comes the understanding. Now what do I need? What is my final remainder of this? Smallest number which when divided by x. X is nothing but 17. So a number when divided by 17 leaves a remainder of 16, and that has to be smallest possible number. So start thinking, which is the smallest number divided by 17 leaves a remainder of 16. So if I say that number is z, if I divide z by 17, I get the remainder as 16. Okay, and which is that smallest number? The same number z, when I divide it by y, I get the remainder as 7, which is not so. If this I divide z by 9, I get the remainder as 7. So what can be the value of z now? If we divide z by 17, remainder is 16. If I divide z by 9, the remainder is 7, which means z is of the form of 7m plus 16. It's a multiple of 17 giving a remainder of 16. It's a multiple of 9 giving a remainder of 7. Okay, that's where you have to think. Multiple of 9 giving a remainder of 7. Multiple of 17 giving a remainder of 16, and it has to be the smallest possible number. I don't want the second multiple here. Okay, so what will that number be? If you can guess it properly, the number has to be a multiple of 9 and a multiple of 17, leaving a remainder of 7 and 16. That is nothing but the smallest number is 16 itself. If you divide 16 by 17, remainder is 16. If you divide 16 by 9, the remainder is 7. And that's my answer. 16 is the final answer. Put m as 0. Okay, you will get 16. Put n as 1. You will get as 16. Okay, so 16 is my final answer to this Chinese remainder theorem.